Greetings. Okay, so we are starting out with Unit 4, which is about conic sections, and we're going to start out talking about parabolas. Parabolas are probably the shape that you are most familiar with out of the conic sections, that and probably circles. So, a few things that we want to establish ahead of time. No matter what parabola we're dealing with, P is the distance from the focus to the vertex or the vertex to the directrix. So in the paper folding activity, we found that every point on the parabola is the same distance from the focus to the point as it is from the point to the directrix. But P is that specific distance between focus, vertex, and directrix. H is always going to be the x coordinate of the vertex, and K is always going to be the y coordinate of the vertex. A couple of formulas. If we just watched a video, I'm kind of talking about where these formulas come from. You don't necessarily have to know where they come from. You definitely need to know which one to use in which situation. So I would absolutely, if you can't print this out, write it down. So for a parabola that opens up or down, meaning that the axis of symmetry, so the line that goes down through the parabola, through the vertex, the axis of symmetry is vertical. You're going to use this formula. 4p is going to be multiplied by the y set of parentheses, and the x set of parentheses is going to be squared. For a parabola that opens left or right, meaning that its axis of symmetry is a horizontal line, those two things are just going to switch. The 4p is going to be multiplied by the x parentheses, and the y parentheses are going to be squared. So we're going to just jump in and do some examples with this work. So what I'm going to do is I'm going to give you an example, and then you're going to pause the video, do your own work on the student work side, and then I'll just give you the answers so you can check your work. If you are not getting the correct answers, then you need to make sure that you get with your teacher about where you might be getting hung up a little bit. Okay? All right. And let's see. Okay. And zoom in on this just a little tiny bit. Started with, there we go. We're going to get started with question 1A. I'm going to do my very best to keep this so that you can see the problem. Okay, so with question 1A, it says, write the equation for a parabola with a vertex at -3, 4 and a directrix at y equals 2. So I'm actually going to take up a little bit of space here. I'm going to take up probably half of this block to draw this picture. We need to make sure that we are drawing these graphs. And if you have the opportunity to, if you have the ability to go ahead and draw the coordinate plane in one color, and then, to kind of differentiate the different pieces of the graph, even better. All right, so I have my coordinate plane drawn, and I'm going to try to draw with a pencil to draw the graph part. So we have a vertex at -3, 4. Now, getting it at exactly the right spot is not that big of a deal, but making sure that you have your vertex, your focus, your directrix in the right position in relation to each other is what's important. So if I have a vertex at -3, 4, that means I'm going to go back and I'm going to go up 1, 2, 3, 4. So my vertex, well, that's a crummy eraser. My vertex is going to be right here at -3, 4. So that's my vertex. I'm going to try to label everything I can. If you have access to some graph paper, that'll help you even more. Okay, so my vertex is at -3, 4, and the directrix is at y equals 2. So I'm going to go up 1, 2. So here is my directrix at y equals 2. And here is my parabola. Okay, the parabola is always going to open away from the directrix. The directrix is outside of the parabola. The focus is inside the parabola. So the focus would be up here somewhere. We'll label that F. So we need a couple of pieces of information. If you look at your formulas here, you need a couple of pieces of information to be able to write an equation. So the first thing we need is P, and then we need H and K. So that's the first thing I'm going to establish. P, let me get my pen. P equals, H equals, and K equals. Take your time to do this because this is where the actual math is involved. The rest you're just plugging, you're substituting numbers into an equation. So P, remember, is the distance from either the focus to the vertex or the vertex to the directrix. Well, I know where the vertex is and I know where the directrix is. The vertex is up here at 4 and the directrix is down here at 2. So they are 2 spaces apart, which means P equals 2. That means my focus would be up here at positive 6. All right, so now H and K are right in the vertex, and we're given the vertex in this question. So the vertex is negative 3, 4. That means H is negative 3 and K is 4. So now I just have to choose the right formula. Well, this is a vertically opening parabola. Its axis of symmetry is a vertical line. So I'm going to use this formula, 4P times y minus k equals x minus h squared. And I'm just going to write that formula. And then I'll substitute in each of my values that I know. So 4 times 2 times y minus 4, there's my k, equals x minus negative 3. Do not get rid of the minus sign just because you have a negative there, or vice versa. Don't get rid of the negative just because you have a minus. It's minus k or h, and if h is negative, then it's minus the negative. So now we just simplify. 4 times 2 is 8 times y minus 4 equals x plus 3 squared. Now, you might see these written in other formats. I have a separate video talking about how to write these in different structures. So if you're not sure how you would say change this so it looks like x squared plus something x plus something equals y, or to get this into vertex form, I would suggest that you go ahead and watch that other video as well. All right, so you are going to pause the video and work on problem 1B. This says write an equation for a parabola with a vertex at 2, 7 and a directrix at y equals 4. So pause, do the best you can with that work. Oh, there was one other thing I wanted to show you. I apologize. So I did want to share with you a great way to check your work is to graph it. So what I would do here is I have graphed the equation that I got, 8y minus 4 equals x plus 3 squared. And then I just want to see, does it fit the description? So this is indeed a parabola with a vertex at negative 3, 4. Here's the vertex right here at negative 3, 4. And then it has a, if I draw in the directrix here at y equals 2, I can go up here to the focus up at 6, and then I see that, like say this point right here is the same distance from the focus as it is from the directrix. It's 2 units, or it's 4 units. It's 2 like major grid blocks. You see how there's some darker lines. This point right here is 2 big boxes or 4 units from the directrix, and it is the same distance. Here's a half, here's a whole one, and then here's another half. So 4 units to the focus as well. So if our directrix is placed at y equals 2 and our focus is placed up here, based on everything else, that all works out. So it looks like that answer is the correct answer. All right, so now go ahead and do problem 1B. I would encourage you to go to Desmos and graph your answer and make sure that your answer is correct. And when you are finished, come and check your work. All right, so for 1B, stop sharing my screen. For 1B, the answer that you should have gotten is 12 times y minus 7 equals x minus 2 squared. All right, so let's jump over to 2A. Once again, I'm going to take about half of that space to go ahead and draw my coordinate plane. So I have an equation for a parabola. I'm looking for the equation of a parabola with a vertex at 4, 1 and a directrix at y equals 3. So I'm going to go over 1, 2, 3, 4, up 1. That's my vertex. And now I need to know which way it faces. I figure out which way it faces by figuring out where the directrix is. The directrix is at y equals 3. So 1, 2, 3. So my directrix is actually up here. So that means that my parabola is going to open away from the directrix. So it's going to open downward. So what that's going to impact is actually what P is. So I want to know, whenever we're looking for P, I want to know, where do I have to go to get from the directrix to the vertex, or the vertex to the focus? So from the directrix, I need to go down 1, 2. My directrix is at 3. My vertex is at 1. So that means that P equals -2. My H, of course, is the x-coordinate of my vertex, and K is the y-coordinate. Now this is also a vertical parabola, meaning its axis of symmetry is a vertical line. So I'm going to use the same formula for P, y minus k, etc. All right, so then I'm just going to substitute -2, y minus 1, and then x minus 4. And then I simplify, I get -8 y minus 1 equals x minus 4 squared. Beautiful. And now if I go over and look at the graph, I go ahead and graph that equation. It would appear that I am correct. This drawing on here looks very similar to the one that I made. I didn't add in the focus on the drawing that that I just did, but if we went down 2 more points, that would take us down to -1 for our focus, which is where this is. with a directrix at y equals 3 and a vertex at 4, 1. I find that if we take, say, this point right here is over about 1, 2, 3 spaces. So it's around 1. We could even go to this one right here. Let's do this one right here. So this one is 4 spaces or 4 units to the left of the focus. So it should be, if we're correct, 4 units down from the directrix. And it is 1, 2, 3, 4 units down from the directrix. So based on the drawing and the parameters that we were given, looks like we got the right equation. All right, so now you are going to go ahead and once again, you're going to pause and work on problem 2b, write the equation for a parabola with a vertex at -3, -2, and a directrix at y equals 1. So go ahead and pause, and then when you're done, come back and check your answer. All right, so the answer to this one, you should have gotten -12 times y plus 2, because we had a negative minus a negative makes it a positive, equals x plus 3 squared. All right, awesome. So let's go ahead and look at question 3a. All right, so 3a says write the equation for a parabola with a vertex at 2, 5 and a directrix at x equals 4. Ooh, x equals 4, they've been y equals 4 so far. Okay, so again, I'm going to take about half of that space and draw a picture. My vertex is at 2, 5. 1, 2, 1, 2, 3, 4, 5. So my vertex is up here. I'm just going to label that V for vertex. And it has a directrix at x equals 4. So that's 2, 3, 4. So my directrix is over here. And again, the scale is not super important that you get that exactly right. What's important is that you get your vertex or your focus, whatever you're given, and your directrix, whichever element you're given, you get those in the right position in relation to each other. So because my directrix is over here, that means my parabola is going to actually open to the left. And so my focus then, if I'm 2 units to the right for the directrix, my focus would be 2 units to the left. My focus would be that's just kind of important for checking. You know, when we check the graph, you don't necessarily need to know that. You definitely, at some point, if you're not given it, you need to know the vertex because the vertex goes into the equation. But if you are already given the vertex, you don't have to know where the focus is. It does help when you check your answer by graphing them. Okay, so I am, if this is where my vertex is, this is where my directrix is. I am 2 units, 1, 2. So that means P equals +2. Or no, I'm kidding. P equals -2 because we have to go left 1, 2 units. So P equals -2. H, even though this is a horizontal parabola, H is and K are still going to be the same thing. So H equals 2 and K equals 5. So I'm going to start with this equation here, 4P times X minus H equals y minus k squared. So whichever, if it's a horizontal parabola, I want my my y parentheses to be squared and my x parentheses to be multiplied by 4p. So I'm going to go ahead and substitute 4 times -2 x minus 2 equals y minus 5 squared. And so this gives me negative 8x minus 2 equals y minus 5 squared. And let's take a look over at Desmos and just make sure that our graph looks like what we want it to look like. So what I've been doing is I've been graphing the equation I got. So I graphed the equation I got, I graphed the directrix I was given, and then I went ahead and graphed the focus just to make sure that my focus and my directrix are the same distance from the vertex, which they are. Here's my vertex here. I'm 2 units from the focus and then 2 more units to the directrix. So that matches up. So this looks like what the instructions said it should look like. All right, so you're going to go ahead and work on 3B. 3B says write the equation for a parabola with a vertex at 0, -6, and a directrix at x equals -2. So that's going to be very similar to this one right here. Make sure that you're using the right formula. And when you are finished, please go and check your graph and make sure that your graph looks like what you think it should look like, and then come back and check your answer. All right, so the equation you should have gotten for this is 8x equals y plus 6 squared. Notice there's nothing in the parentheses with the x because the vertex is at 0, -6, so h is 0. So we simplify that down to 8x. All right, you're doing a great job. We just have a few more problems to do. All right, so 4a says write the equation for a parabola with a focus at -6, 4 and a directrix at y equals -2. So the focus is different. We've been given the vertex all along. We need the vertex. So I want to make sure that we remember we need the vertex for our formula. So again, I'm going to take about half of the space and I'm going to draw a picture. This time the focus is at -6, 4. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So over about here. I'm going to label that F. And this is terrible, but once we use F to figure out what the vertex is, we're going to get rid of it because F can confuse us. All right, so our directrix is at y equals -2. So that's going to be down here, down below the x-axis, or yeah, below the x-axis at 2. All right, so our vertex is the same distance from the focus as it is from the directrix, which means it's halfway between. So if this is up here at 4 and this is -2, that means this is 6 spaces apart. So halfway would be 3. So 1, 2, 3. So my vertex is right here. And the coordinates of my vertex are going to be, this was what, -6, are going to be -6, +1. -6, +1. So that's what I care about, is the vertex, -6, +1. Now, to avoid any sort of confusion, I'm going to scribble out this focus. I'm even going to scribble out this one. I want to look at the vertex. So my directrix is down here. My focus was up here till I scribbled it out. The parabola wraps around the focus, away from the directrix. The parabola goes this way. So it is a vertical parabola. So I'm going to use that formula where the x parenthesis is squared. So 4p y minus k equals x minus h squared. P, we said was 3 units. It was 3 units down from the focus to the vertex, 3 units between the vertex and the directrix. we wanted to go from the directrix up, which is what we need to do, is 1, 2, 3 units. So P equals +3, H equals -6, K equals 1. And this is why I crossed this out, because as I was looking at that, I had a little tiny panic attack that I was writing down the wrong coordinate. So once you are done with something like that, get rid of it, cover it up, cross it out, something, so that you don't use it by accident. All right, so 4P is going to be 4 times 3, y minus k, k is 1, and then x minus -6. Remember, this is negative. That negative does not replace the minus sign. It's minus -6. So this simplifies to 12, y minus 1 equals x plus 6 squared. And if we take a look at that on the graph, this is basically what our graph looked like. Our, wait a minute. That's not right. That should be 1. What am I doing? And then our focus was at -6, +4. I crossed it out. 4, right? There we go. Had those backwards. So here's our focus up here. Our focus is 1, 2, 3 units, 4 to 1. Here is our vertex at -6, 1. And then if we go 1, 2, 3 units up from the directrix, we get to the parabola. We go 3 units further up, we get to the focus. This point over here would be a great point to check and make sure that I've put my focus at the right place. This is going to be 2, 4, 6 units to the right of the focus and 2, 4, 6 units down to the directrix. So that is where the directrix for that particular parabola belongs. So it looks like everything works out that our equation is correct. All right, so you are going to go over here to 4b. It says write the equation for a parabola with a focus at -2, 5 and a directrix at y equals -3. So go ahead and take a few minutes and work that out. I encourage you to graph your solution so that you, or graph your equation so that you can check your answer and make sure that you got the right equation, and then come back and check your work. All right, so what you should have gotten here for this is 16y minus 1 equals x plus 2 squared. Your vertex, I actually messed this up the first time that I did it, and another teacher had to point it out to me. So there's no shame in making mistakes. We just have to figure out how to make sure that we don't keep making the same mistakes over and over again. I actually, when I had originally done this problem and sent out the answers to all the other teachers, I used the focus when I wrote my equation instead of the vertex. So just make sure that you, like I said, cross that focus out when you're done using it. Okay. All right. So question 5A, we're almost there, you guys. All right. 5A says write the equation for a parabola with a focus at 2, 6 and a directrix at x equals 4. So I know that the x equals 4, what that did was gave us a horizontal parabola last time. So it's probably what it's going to do this time. So it's good to kind of be able to make a prediction about what you think you're going to see. Just make sure that you don't accidentally force something to fit your prediction. But let's see, we have a focus at 2, 6. So 1, 2, and up 1, 2, 3, 4, 5, 6. So we have our focus right here. I'll cross that out, 2, 6. A directrix at x equals 4. So this would be 1, 2, 3, 4. Nope, That's y equals 4. Why do I keep doing that? X equals 4. That's 2, 3, 4. Okay, so our parabola is going to open away from the directrix and around the focus. So our parabola is going to open to the left. We have a very tight space in here to fit into. Our focus and our directrix are only 2 units apart. So what that tells me is that P equals 1, and because from the directrix to the vertex, which will be right here, is only 1 unit to the left, because our parabola is going to open to the left, P is going to be negative. So there's my parabola right there, opening to the left. I don't even care about that focus anymore. My vertex is at, I went over 1, so that's 3, and then up 6. So 3, 6. So H is going to be positive 3, and K is going to be positive 6. All right, so now because it's a horizontal parabola, I want to be squaring my y parentheses. So my x parentheses go with the 4p. So 4 times -1, don't forget your negatives, x minus h, so x minus 3 equals y minus 6 squared. So it's -4 times x minus 3 equals y minus 6 squared. Beautiful. Let's go ahead and check the graph for that one. All right, so we are looking for a parabola that opens to the left. This one opens to the left. It has, if we got the right formula, it had its vertex is at 3, 6, which is what we calculated. What we want to know is, does the focus and directrix work? So is this, given the equation we came up with, is the focus and directrix we were given the right one for this equation? So we have a directrix here at x equals 4. We have a focus here at 2, 6. And if we look at this parabola that was graphed, because these don't all get graphed together, I graphed the equation that we came up with, and then I graphed the pieces of information that were given to see if they work. Because if we had the wrong equation and we went ahead and graphed this focus and this directrix, they wouldn't work. I'll show you what I mean in just a second. So this does work. It's one space from the directrix to the vertex, one space from the, or 1 unit from the vertex to the focus. If I take a look at, say, this point up here, right here, I am about 2 units from the focus and 2 units from the directrix, because each dark square is 2 units. So I'm 1, 2, and 1, 2. So that seems to work. Now, this is what I'm talking about. If we had, we were given that the focus is at 2, 6, and the directrix is at x equals 4. If let's say we did, let's say I got this number wrong. Let's say I did a +2. Okay. So I graphed this parabola with +2, or -2 instead of -4 like it was supposed to be. And I put the focus and the directrix that I was given. Okay. If I look at this point, right, this point right here, I'm about 1.5 units from the focus, but I am 2 units from the directrix. So that doesn't work. I know that my equation for that parabola is wrong because it does not work with the focus and the directrix that I was given. Okay. So that's how these graphs can help you make sure that what you're doing is correct. All right. So, you know the drill at this point. Pause for a moment, go take a look at 5B, and then we will come back, pause. All right, so for 5B, you should have gotten 12x minus 5, that's a 5, equals y plus 1 squared. And again, if you are not getting some of these answers, you're not sure, you can't figure out where your mistake is, reach out to your teacher and make sure that you get those things resolved, because we want to make sure that you understand what it is that you're doing. All right, so let's move on to this last one. This is a word problem. All right, so 6A says the dish inside of a flashlight is parabolic, meaning if you kind of cut a slice through the dish, I'm actually gonna, so if you look inside, not so much like LED flashlights so much anymore, they tend to have different shapes. But if you look in like an old school flashlight that just has a bulb inside, the bulb sits inside of this like dish, like a bowl. And there's a little hole right here, right in the center, that the light bulb goes through, and it touches the battery underneath. And the light bulb little contraption is here, and then you have the light bulb. Ding, light bulb. Okay. That's a terrible drawing. I apologize. So the reason that that dish is shaped that way is because if you were to just take a light bulb and attach a battery to it, preferably a battery in a case so you're not burning your hands and stuff. But if you were to just attach a light bulb to it, essentially make it a lamp, the light would go everywhere. If you want it to be handheld, you want a little tiny light, and you want to be able to produce as much light as possible with that little tiny light. You want a lot of light, like a high ratio of light to light bulb. Okay, we put a pretty big bulb in a lamp to light up an entire room. We wouldn't want to carry around a flashlight that took a light bulb the size of like a lamp. We want something that's compact and small. So in order to make up for the fact that the light bulb is really small, what people have figured out to do is to put it inside of a bowl, a reflective bowl, because the unique thing about things that are parabolic is that as this light bounces off from the light bulb at a specific angle, it bounces back out, and all of these beams of light bounce back out, and they all end up going out at the same direction. So instead of just bouncing all over the inside of this parabola, it creates a beam of light shining out the dish, and it kind of concentrates all that light. So in order to make that happen, though, the light bulb has to be at the focus of the parabola. So if we were to take like a cross section, if we were to just cut down through the middle and look at it from the side, this is kind of what it would look like. And with the light bulb at the focus of the parabola, otherwise it doesn't work. So now that you know that, this problem says placing the bulb at the focus of the dish allows the light to be directed out in a beam instead of scattering in all directions. If the light bulb is 2 inches from the vertex of the dish, write the equation that would represent the parabolic cross-section of the dish. So essentially what we want to know is the equation for this parabola right here. So I'm going to take that parabola and I'm going to take it out of my picture of the flashlight and I'm just going to make it a parabola. And it says, so this is the vertex of the dish. It says the light bulb is 2 inches. So this is 2. Well, it kind of looks like, if I'm looking at the distance from the vertex to the focus, that's P. So P equals 2. Now, we also need H and K, and H and K are your vertex. Well, I don't have a vertex here, and there's no particular like orientation a flashlight has to be at. So to make my life easier, I'm going to say, you know what, let's orient this flashlight on a coordinate plane. So let's make H 0. When you're dealing with real world objects, if you can set a key point at the origin, you are going to make your life so much easier. So in this case with parabolas, we want to look at where the vertex is. We can put the vertex at 0, 0. You're going to take a difficult problem and make it twice as easy. Okay, you're going to cut the difficulty level in half. So now I have all of my information. Now I've made this a vertically facing parabola because it doesn't say which way it's going. The only way it would make any kind of difference is if like you were trying to put it into a machine, like you were trying to get a computer program or something to like model the dish, and then you would have to orient it in the program. But since we're just talking about a real dish and trying to come up with a formula, just make it face upward. Again, make your life easier. All right, so I'm going to use 4p y minus k because I have it a vertical parabola. So my x parentheses needs to be squared. My p is 2 y minus 0 x minus 0 squared. These minus zeros are inconsequential. They don't change the value of anything. So what I get here is 8y equals x squared. And if we take a look real quick at the graph of that particular equation, that looks just like my drawing. Here is our parabola that represents the dish of the flashlight. My focus is 2 units, so inches, above the vertex. So if I place a directrix 2 units below the vertex, and I just check points. So let's see, this is 4 units to the right of the focus and 2 units above the directrix. That seems like a good equation to fit the description that we were given. All right, so in 6b, a satellite dish is a parabolic figure also. So when we talk about satellite dishes, I know a lot of times what we're accustomed to is seeing like the DirecTV dish or something outside of your house or somebody else's house. Let's think big satellite dishes, like what television stations and stuff use. You may have seen them on television. You might have seen them in real life. There are a few places around that I've seen that have satellite dishes, but these are those things that are like bowl shaped, basically, sort of. Sometimes they're more flat than anything, but they're roughly bowl shaped, and they have like these things that stick out. This thing right here is the receiver. So this says the receiver is situated at the focus of the dish. It's very important that those aspects, when you're using something parabolic, like a satellite dish or a flashlight or something, that those, that like your receiver, your light bulb or whatever is at the focus. So the receiver's at the focus, the vertex is over here, and it does say that the dish points to the right. So I did set this drawing up for you so that it's pointing the right way. So we would want to look at something like this with a focus out here. So I'm going to let you go ahead and pause, continue on with this drawing, come up with your answer, and then when you're finished, I will show you the equation you should have come up with. All right, so the appropriate equation for this is 16x equals y squared. So the y is squared because it's facing to the right. Our p was positive because it was facing to the right, not the left. And if we go ahead and situate our vertex again at 0, 0, okay, you guys, this video is cursed. My phone just died. So I'm gonna the time I'm trying to make this video. Okay. All right, so if you go ahead and set your vertex so that it is at 0, 0, then that makes it so you don't have an H or a K that you have to deal with. All right, so if you have questions about any of these things, please go ahead and reach out to your teachers. Otherwise, go ahead on back to E-class and move on to the next activity.